Bismillahir Rahmanir Rahim. I start this with the name of Allah, the most compassionate and the most merciful. My name is Muhammad Kamran Azeem, and I bring you these CBTs or video training on virtualization. Uh, Basically, the idea was to create a CBT on XEN virtualization, but later on I thought that it would be a restricted topic, so I decided to include KVM and other technologies as well. The main another one of the ideas was to prepare people or whoever is interested in appearing for the virtualization exams, such as Red Hat's virtualization exam RH184. So this video training could be helpful. It had been in planning for a very long time, I must say 1 year now. I had all the hardware, everything ready, but I couldn't get time. It's only recently, this past week, that I decided, okay, let's burn some nights and do this. Luckily, the time I'm making this right now, it's daytime, and I luckily have my kids not making much noise at the moment, so I decided to go ahead and start off. Virtualization. Okay, here's what I'm going to cover. I'm going to cover first of all the theory behind virtualization, what exactly it is, because jumping right into how XEN is installed and how various virtual machines are created is probably a common method which I would not follow, because I'm here to try to teach you or try to show you what exactly virtualization concept is. And later on we'll move to the real action. There's plenty of real action. We'll be creating virtual machines as file on a partition on LVM, and we'll be moving the virtual machines across various physical hosts, live migrations, etc., etc. We'll be doing a lot of cool stuff, as you might say, and interesting stuff, as you might call it. So I decided to first cover what virtualization actually is, and I created this document. There's a reason behind this document. Actually, I first started off with my OpenOffice presentation software, but then these points, once I was collecting them from here and there, they used to cause a real bad ripple effect. So it became kind of nightmare for me to adjust all these slides just because of one point. So I decided, let's go ahead with this wiki idea and create one big page, and hopefully my viewers will not have any problem to it. It's kind of, it will feel like I'm reading the text out to you, which you can also read by going to this website of mine and reading it yourself. So I'll not exactly be reading it out. I'll just be covering it or touching few things here and there, and then we'll move on to the much anticipated real action. So this is what I covered just now, why I created this document. By the way, we are also going to cover the Citrix XEN server in the later parts of the video. Fine. So what exactly is virtualization? It's a method to create, in a very layman terms, it's a method to create a so-called virtual machine or a PC or a server inside an already existing PC. So it's running multiple PCs within one physical set of hardware. This was not this was a difficult concept to understand if you go back about 10 years from now or something like that. But now it's more of a common term, and almost like everyone understands this much part, that yes, virtualization is like running multiple instances or multiple operating systems inside one PC, and most of the people are familiar with this term in the following way, that they can run Windows inside Linux. And it's not, by stating this, they do not mean, and I do not mean dual boot. No, I'm not talking about dual boot. In dual boot, you only have one operating system loaded at one time, and if you want to load the other operating system, you have to reboot your physical machine and load the other OS. However, in virtualization, you run the so-called base OS. It might be Linux, it might be Windows, and then by using some sort of virtualization or in other words emulation software, you kind of create a PC inside that physical PC, and then you install your other OS on that virtual PC, so to speak. This is what virtualization is. Now, what's the benefit? Fine. So we'll cover the benefit. Let's cover it now. Why would someone do this thing, that like creating a virtual machine inside a PC? The idea is, if you want to test a couple of things, if you want to run some network oriented applications and want to test them or develop them, and you either cannot afford or you don't want to buy more physical PCs for X number of reasons, including money, power, desk space, etc., then virtualization is the way to go. You can create multiple machines inside your physical PC or physical machine and install different versions of operating system on it, and go ahead with your development and testing and whatever, and do it. This has been a very famous testing infrastructure, so to speak, for various system administrators across the world. I remember especially Linux people, they are very fond of creating multiple Windows machines and multiple Linux machines inside one physical PC, and testing various Samba configurations, various Apache configurations, and whatever you can throw in, you can just go ahead and test it, because there's a network, virtual network, which exists inside your PC, and you don't need any piece of physical equipment other than your own PC, and that's all. Means you don't need a KVM, means the keyboard, video, mouse, physical. You don't need that. You don't need a physical network switch. You don't need any other extra cables, extra power, etc. Just your PC, and that's all. The only optional thing you might want to have is like a connection to internet, which is nowadays kind of a normal to have. Right, so we'll cover the more benefits a bit later. First of all, how virtualization started off. Basically, it's kind of an old idea which started in 1966 by IBM. They created this IBM System 360, which had the facility to run kind of multiple instances, time shared multiple instances of the same operating system. This idea was, it kept and they kept enhancing it, and eventually, but remember that virtualization exactly was not the whole idea behind creation of this System 360 or the later model. It was just an added benefit or added advantage of the design, not the main design goal. Later on, in recent years, like 1998, let's say, there was a need that power was becoming expensive, and people thought that okay, let's have something, some sort of virtualization. They coined in this term and wanted to utilize the PCs or the hardware lying around and reduce the heat and the gases, the harmful gases emission and all that. This whole greenhouse thing, when this started going on, then people started thinking of alternate ways of making a more efficient computing, and naturally they thought that if their PC, their servers are not efficiently utilized, then why not create multiple instances of various operating systems inside one physical infrastructure and go ahead and utilize it fully. That was the basis of the modern day virtualization, although I just stated that in 1966 IBM already had it kind of working. So VMware, they founded in 1998, and they released their VMware workstation pretty soon. VMware in that time, 1998-99, it was emulation software. Means you can run you could run like Windows inside Linux, or in Linux inside Windows, or even Sun, or whatever. You can just use them on 32-bit mode. So, and VMware is right now the most popular virtualization technology, I must say, and is the giant in virtualization right now in the IT field. In 2003, XEN came out as a research project. It was actually named as XenoServer, and at University of Cambridge, this Ian Pratt, he proposed along his fellow students or fellow research members a paper that how we can use para-virtualization and cut the overheads of the emulation virtualization which VMware was offering. Remember, I just told you that VMware in the beginning was just offering emulation. And emulation means that the whole PC, the processor, RAM, VGA card, and a couple of peripherals, they were all emulated inside your base OS to fool the other OS, to be precise, that look, you've got a fully functional PC for you, so just go ahead and keep working on and install and start working on this one. So it was an emulation solution in the beginning. Then they decided that we can use para-virtualization. We don't have to actually emulate anything. In fact, the guest operating system, means the operating system running on the virtual machine, would know that it is running on a virtualized machine. So most of the emulation parts were skipped, and by skipping that, a lot of overhead was reduced on the physical host, and machines ran pretty fast. In fact, Xen para-virtualization is supposed to be the fastest till now. Then this is all detail of when Xen was released and when Citrix acquired it in 2007, and what are Xen management tools like Xen tools, and we have Convert and etc. Xen supports for us now, like we call them old computers, but any computer which is 32-bit capable and with physical address extension support can run Xen. So it's kind of Linux philosophy that Linux also runs on almost every hardware you throw on it, and Xen, I'm pretty sure that almost all the hardware or architecture, the different PC servers available nowadays will run on almost all of them, and also a bit older PCs like let's go 5 years back, it will still run, because physical address extension has been around for a very long time. Okay, so Xen supports para-virtualization and also supports full virtualization. And since full virtualization came out with Intel VT or AMD V in 2005, full virtualization means that it can use these processor extensions specifically designed for virtualization. We'll cover that later. QEMU or QEMU, a quick emulator, or what, I couldn't get its correct name or the detail or the actual logic behind this name, but it's an emulator, and it was proposed in 2005 by Fabrice Bellard in the Usenix 2005 conference, and they proposed that they can create a full virtualization, a full emulator of a PC. The difference between this one and VMware was that this was open source and GPL. And I've got this link here for you. You can just open this and open the full technical paper on this, what they proposed. QEMU basically has the facility of emulating ARM processors as well, the RISC-based processors, and it means it can emulate different processors, not only PC x86 32-bit or 64-bit. So it has capability of emulating multiple processors and multiple architectures, you can say. So it's very powerful, very useful to if you got to test your application, your code or whatever on different architectures. QEMU is the best open source solution available to you for that matter. By the way, QEMU is used, its code is used by KVM, its code is used by Xen, and its code is also used by Virtualbox, Sun Virtualbox, which has now sadly been acquired by Oracle. Okay, so and QEMU uses BIOS code from another product or technology known as Box, but it's called, it's not spelled as Box. Let me search for it. Box.org or something. No, sorry. No. Okay, let's search here. Okay, this one. Okay, their site is down for some reason. Let's see. I have this. Let me show you. I have this. Where is that box? Yeah, here. Okay, this is my other PC, so I'll just bring it here. This is that box which I'm talking about. It has got a lot of BIOSes for many different architectures. Basically, it's cross-platform IA32 emulator. Just for the sake of extra information, I just brought it up. Alright, so what else we have? We have KVM. Okay, so what is KVM? KVM stands for kernel based virtual machine. For Xen, you would boot your operating system in such a way that kernel Xen is the main kernel, and the operating system and the kernel of your operating system boots on top of it. So it means that if you need to run a so-called normal kernel, you would need to reboot your PC and go ahead and use the normal kernel. However, in KVM, you don't have to use that kernel Zen anymore. The normal kernel, Linux kernels, has this facility of virtualization in it, so you don't have to reboot at all. However, please note that KVM will not work if you don't have Intel VT or AMD V extensions in your processor. This is very important to know. So that means KVM, if you want to use KVM virtualization, you can only use it on most recent processors available, like let's say 2 to 3 years old from today, which is 2010. So let's say safely 2007 onwards. I must say any processor created after that, it would definitely be able to run KVM. However, please note, by stating this, don't take my word for it. I recently had a friend of mine who came to me with this super laptop from, I suppose, Dell. It's Dell Studio something, very big laptop, 15-inch or whatever. Main thing in it which I totally dislike, that this guy bought it for so much, huge amount of money for him, and it didn't have this Intel VT or AMD V extensions in it. It's an Intel laptop, so let's talk about Intel VT. It doesn't have this processor based virtualization extensions, and I spent a day installing Linux and then KVM and configuring it. Then at the end, once I started creating virtual machine, I saw, oops, but I was under an impression that this is the latest laptop, so it must be having it. Anyway, so don't be warned that please check whenever you're buying your PC or whatever that it should have this Intel extensions. Check internet, check your vendor, whatever. It should be there. KVM can be managed by this overt, very nice piece of software, open source, capable of all live migrations, etc. And of course, your virtual machine manager, the default which comes with Linux nowadays, is always there. You can use this virtual machine manager with KVM and Zen both. And if I can give you a quick look here, let's say this is a this is your I'm running this presentation off a Zen machine, physical machine. This is what virtual machine manager looks like. So I'll say connect. Oh, there must be some service which is down, so I'll check that later. But anyway, this is how this looks like. So you can just add more connections, check certain host details, check the number of virtual networks and storage pools, etc. So this is Red Hat's default GUI interface for managing Zen and KVM virtual machines. Alright, parallels. There's a lot of name. This name I've heard a lot in industry. Parallels. This is also a company which creates these virtualization software. The main idea behind Parallels is Virtuoso, or jail-based virtualization. Now, what is jail-based virtualization? We'll be covering this very shortly. Just it started in 2005, of course, and it is nowadays delivering quite high quality virtualization solution. And this is what Parallel Virtuoso Container is. It's a system level virtualization product. It's like creating change root jails inside one PC, inside one not PC, I'm using this term again. Inside your OS, you can create multiple directory hierarchies similar to your base operating system hierarchy, and create change root or jail environments for your virtual machines. This was formerly known as SWSoft, and now it's Parallels. This is what we've also seen in our company recently. These machines were brought in. They have capability of running or using this VTD, Intel VTD, full GPU acceleration. That means they can run they can use two different hardware VGA cards and drive two different monitors, etc., for various visualizations. So the company where I work in right now, almost everybody knows that they are the heaviest users of this computing and visualization tools. Of course, it's an oil and gas company, so all right. So what's OpenVZ? It's a quite popular virtualization solution. It is the jail-based or change root-based solution. It's the same as Parallels, or I must say Parallels uses this technology. I must have mentioned it somewhere. Yeah. OpenVZ is the basis of virtuoso containers. So I've already just mentioned what change root environment is. It's a copy of your main operating system hierarchy in a separate directory under a separate tree, and then when a virtual machine boots up, it boots up in a separate directory. It's not technically boots up. It uses the same kernel most of the time, although it can use a different version of a kernel, but not altogether different type. So if a physical host provides OpenVZ solution, that means, and it's running Linux, that means you're only going to have Linux-based virtual machines running on it. No Windows, no Sun, no Solaris, no Unix, etc. Because it uses the same copy of the kernel, or at least the same type. They claim that they are very fast, like only 1 to 3% of degradation or overhead. However, because it's highly dependent on the base operating system's kernel, so it's risky as well. Some people consider it risky, that if the base OS goes down or the kernel, there is a problem in the base OS kernel, then that problem is reflected on all the virtual machines. Okay, Virtualbox. Previously it was under Sun's name, and now this company has taken over it, as if they'll take over the whole world. But anyway, Virtualbox is very nice virtualization emulation software. It was created by Innotech, and then it was taken over by Sun, and which was taken over by Oracle. It's an open source, you can say, virtualization solution. Very nice. Runs on Windows, runs on Linux, runs on Sun, and can support all these operating systems like Mac OS, Windows, XP, Vista, Solaris, Linux, etc. And it's, as I've seen it, I find it faster to Vmware Workstation series. It's very straightforward. It's got very good BIOS options like boot from Pixie and boot order, etc. Lovely stuff. It's very good. I've been using it. It's open source right now, and very good again. Other virtualization solutions available in the market are like Virtual PC, which Microsoft created, Hyper-V, Microsoft Virtual Server, QEMU we have already discussed, Denali was a research project. Alright, so the following uses full virtualization. These AMD V or Intel VD technologies, KVM, Virtualbox. XEN can use it, I told you earlier. ESX server is different product than VMware Workstation. ESX runs directly on the hardware, whereas VMware Workstation runs on the host OS. So naturally ESX servers is faster, and we'll cover this down later, just shortly, uh, that what these things actually mean. What difference does it make if it runs on the host OS or if it runs on the hardware directly? These are important concepts. If I sound going into too much detail, or I sound boring, don't be, because these are the foundation of your virtualization concepts. uh, just bear with me for a while. So virtualization terminologies, I think let's cover that in the next video, so that you'll have a decent time of viewing each one of them. Alright, so we'll cover virtualization terminology and virtualization. What else we have? Virtualization advantages, etc., and technologies in the next video. So let's go up again. Oops. Here. I'm gonna stop here, and I'll be back shortly with the next video.